The next three videos are going to cover the fundamentals of kinematics. We'll derive some foundational equations that cover the relationship between velocity, acceleration, and position. We'll focus on the case that covers a variety of applications in physics, such as objects falling under the influence of gravity. Constant acceleration. Constant acceleration doesn't just arise in the case of gravitational freefall. Later on, we'll see it arise in, for example, objects being pulled by a constant electric force toward some other object. To get a bit advanced in the next part, if acceleration is some constant a, that's the derivative of velocity with respect to time, then if we sum up or integrate all the changes in velocity over some time interval t, then at time t, the new velocity, v sub t, will be the initial velocity, v sub 0, plus the acceleration, a, times the time t. From this equation, we can prove three more equations of kinematics that will prove extremely useful for solving problems throughout physics. First, we can prove that the position of the object at time t, which is denoted x sub t here, is the initial position x sub 0 plus v sub 0 times t plus 1/2 a times t squared. From this, it turns out we can derive two more key equations. First, an expression for x sub t that is useful when we know the velocity at time t, but we don't know the initial velocity v sub 0, and that equation is similar to the first equation, except we substitute v sub t for v sub 0 and subtract 1/2 a times t squared instead of adding it. Finally, we get this third equation, denoted 2 here, that can be used to solve for example, v sub t if you don't know t. V sub t squared equals v sub 0 squared plus 2 times a times the distance the object has traveled, x sub t minus x sub 0. In the next video, we'll dive in and start proving the first of these three equations.